Hello and welcome to PCB Chat, where we talk with experts across the printed circuit design, manufacturing, and electronic supply chain fields. I'm Mike Buteau, president of the Printed Circuit Engineering Association. My guests today are Jack Fisher, project facilitator of the High Density Packaging User Group, also known as HDP, and his colleague Madan Jagernauth, who is the marketing director and also a project facilitator. Thank you both for joining me on PCB Chat.
Thanks, Mike.
Thanks, Mike. Good to be here.
So let's start with what's new. I understand you have started a new technology direction initiative to consider projects that are focused on enabling technologies. What can you tell us about that?
That's true, Mike. HDP is a bottoms-up organization versus some other consortia that are tops down. And to explain that, it simply is if you have a roadmap or some source that you get your projects from, that would be a top-down version. A bottoms-up is where the projects come from the members, and they come to a member meeting and suggest new projects to us. And that's been working for 30 years. But we also want to stimulate their thinking. They're all busy. They got their own jobs, their own things, and HDP doesn't pay them anything. And so we need to get them stimulated sometimes with new ideas that they may not have in their chain of command at work. So we developed a technical direction for HDP this year. Actually, we developed it last year. It actually came from our board of directors asking the question, what is HDP's technical direction? Where are you guys going? This is our own board asking that question. And it was a good question. It was a proper question to ask from the board of directors. So when we first got this assignment, we all said, what is the technical direction? What's the difference between a technology roadmap and a technical direction? And so first we in the small group that we had working this, we identified the differences between those two things. A technology roadmap is a document that predicts the technology advances of the industry, but it doesn't pick technology winners, nor does it determine which company will work on which project. Or on which technology. A technology direction is different. It's a corporate technology direction, and it sets the path for the company or the organization. In our case, it allows the organization's members and prospective members to understand the path the business has set as a priority. So it takes the general technology, new technology that you read about every day on the internet or in the newspaper or in magazines, and says, in HDP, here's the ones we're focusing on. Here's the ones that we think are the most important. So then we went through all the worldwide trending applications, AI and robotic and automation and virtual reality, blockchain, 5G, all of those things. And we came up with a list of what we'll call emerging technologies that fit into HDP umbrella. Printed circuit boards, printed circuit board assembly, etc. So then we had those focus ideas, you might say, or emerging technologies. So then we broke them down. We said, for example, if it's high-speed materials, what is needed in high-speed materials in the future? And it could be like different testing, different heat characteristics, electromagnetic performance, reliability, etc. So we did that for each and every one of those ideas, emerging technologies that we picked, and then to take it down a step further, we said that's really too much for our members to absorb right at the time. So how do we take that down to something that they can currently put their hands around? So then we drilled that down to the areas that fit best within the HDP umbrella. And there are 5 of them right now that we've selected. And high speed materials happens to be one, solder alloys is another, copper density technologies is another, methods of reliability assessment is another, and flex materials is another. So those are the 5 emerging technology areas that we're setting aside as the technical direction of HDP. And I presented that to the board of directors last year, and then I presented it to the members in October of last year. And for this year, we've incorporated it into our operating plan, or at least some of it is in our operating plan. So that's what we're doing with the technology direction. We don't have a roadmap, and we never will. That's not in our mission statement, you might say. But we think we have to show our members that there's other things than the little world that they live in, and on the manufacturing line or whatever it is in the drill room that they're the engineer in or something like that. So we want to expand them, and so at every member meeting, I present an update on this technology direction. We also use it to bring in guest speakers for our member meetings. And we want the last one we had in February was somebody that spoke on 5G. And this time we're hoping to get Jan Vardaman. I haven't got her yet, but we're hoping. And she's a busy lady. So that's what the technical direction is all about, Mike.
Jack, so thank you for that explanation, particularly as it pertains to the differences between the technology direction and roadmaps themselves. And for listeners who aren't aware of this, I've known Jack for going on 30 years, and we worked, he worked, and I kind of watched and listened when they developed the first interconnect industry technology roadmap back in the early 1990s. Through the years, that roadmap, continued to be developed and worked on. But one of the things that I always questioned about roadmaps in general, I felt like they're necessary. I still do, but I felt like they never really showed. They couldn't predict dramatic changes, right? They really kind of showed technology evolution, and they're not really designed to predict the unexpected, right? I mean, that's just
right.
not what they do. So, but it is interesting to me because what it sounds like to me with the technology direction is you're really kind of starting with the application and working backwards from there. Is that a fair statement?
That's a fair way to look at it. Yes, I would say that's a. I hadn't looked at it first that way, Mike, but it is. It's a good analogy.
And it sounds to me that this also is something that separates HDP from some other technology consortium, equally important, but just kind of working in a little bit different space, like INEMI.
That's correct. We are different, and we're not competitive. We're different. And if you join another consortium, whatever it may be, you have to look at the level that it's looking at. Is it looking at industry and changing the industry, or is it looking at changing the shape of the drill room in a factory? And that's what we do.
Right. It's really HDP is really where the rubber hits the road.
Yes.
Jack, when all the research on a particular project is done, what do you hope to be able to deliver to the members?
That's a good question. And every project that we have, our projects are in 3 levels: idea phase, definition phase, and implementation phase. The facilitator who has a project assigned to him has to put together a series of charts, and one of them is the benefits. What are the benefits of this project? Who gets results? Who gets value out of this project? And hopefully, all of them our members do. That's one. But in some cases, it's the industry. We may change a spec or recommend it to IPC or to some other industry, or that they want to change a specification. or it may be a publication, a report at one of your meetings, Mike, or at Apex or something like that, where we just present the data that we collected, and you, the member, makes the choice on whether it fits into your model of your factory or not.
I don't want to step into anything that's proprietary here, but could you walk me through what it would look like from, say, I have this application of autonomous automotive, right? So then how would that then be sort of filtered down into the areas of focus? Like, for example, high-speed materials or solder alloys.
Yeah,
How would that
yeah.
flow down?
That's a good question, and it's a difficult answer. uh, Autonomous autos, that's a huge thing, and there are 1,000 or 2,000 subcomponents of that. We try to break it down in our technical direction into things that our members might be interested in, might find the most value in. And that's why we brought the technical direction into those 5 different emerging technology areas. And so we would take the autonomous auto and bring it down into something that would be like, what are the materials that may be required for autonomous auto? Or what is the solder alloys with that high temperature under the hood thing? Does that change? Reliability assessment of automobiles is completely different than reliability assessment of a computer in your home office. We try to take the big picture and break it down into more usable areas for our members. Now, our members are always allowed to add their ideas too. We don't just restrict it to these 5 that I've mentioned, but this is the ones that the facilitators, the staff have picked to get started with.
May I add to that one specific example? For example, so there's a new project started recently that's final finish for high frequency. Right, there's this final finish in over copper. There is some concern that when you're dealing with high frequency circuits like radar and automotive, which operates at 77 gigahertz, that you may get some undesirable effects based on what coatings you put on top of the copper. Right? There's a project that just started to look at specifically what the effects of surface finishes are on these circuits. And the team is looking at what is the correct range of frequencies to test for insertion loss. And that's a project in the idea phase right now that members and non-members can contribute to defining what HDP actually looks at in something like that could have a large effect on the industry.
I see. So if we could, kind of keep with that thought, Madan, could we talk a little bit more about what the board level considerations might be?
Some of the things that they would look at are things like, well, how do you lay out the circuits on the board? What are the actual dielectric materials that would be applicable? Is it liquid crystal panels, or do you use ultra low decay substrates for this kind of a circuit? And those are questions that the team really have to look at to say what type of laminates you use or what type of board structures you use to get the effects that you really want, and what are the results that you get out of testing for these types of materials. So it's investigative work. It's work where detailed questions are being asked, and we don't know what the answers are until you actually set up the project, get a design of experiments that say what's included, what's excluded. Because for stuff like this, you really have to be very specific about what you're including and what you're excluding. Otherwise, you try to boil the ocean and you get nothing.
I like how you put that. And, and the goal here, of course, is this isn't just being done as an exercise. It's being done, as Jack mentioned earlier, because we may need to reshape the drill room, or as you mentioned, you want to get the information back in the hands of the design engineer because it will influence the way that they are going about designing next generation product, or even current generation product for that matter.
Yeah. Yeah.
Oh yes, and basically all of this starts with someone in the supply chain having a specific challenge that they're facing, right? Whether it's one of our members who is a material supplier, for example, being asked by an OEM, how do I solve this particular problem? And then the beauty of HDP is that we have folks that represent the entire supply chain, from laminate suppliers to material suppliers to the OEMs that are asking questions about how do I actually implement something that will give me the results I desire.
Now I'm going to stick on the automotive topic for a moment, not to pigeonhole HDP into that particular application, because obviously there's others. But as Jack noted, there's just so many variations to all this. We could probably talk forever and a day, and not even get anywhere close to being done. But my understanding is that HDP recently completed a project on manufacturing for automotive applications, specifically for reliability of routable QFNs for automotive. What can you tell us about that?
So that's a project that was initiated by a member specifically because there was a challenge in terms of how these devices, the QFNs, what the solder joints were looking like. So they were looking at a specific configuration of QFN and the way the component was being modified to see if they could get a more reliable solder joint with this particular component. And it was for automotive applications, right? Right in the name, it says for automotive. So this was a project that is just being wrapped up now. I think the final report is being written. And as you know, I don't know that they will actually publish that publicly. So it is a report that will be available to members only as we get this project done.
So I'll talk about that, the way that HDP works in that respect in a moment. I want to ask about this. When we spoke last fall with Larry Marcanti, who is the executive director of HDP, there were 24 active projects. It looks like HDP has added 4 more since then for a total of 28.
We get new current projects all the time. In fact, I got one today from Carl Sauter at Oracle. I mean, he just Carl is one of those guys who just contributes and contributes and contributes, and so he just sent me a new one, and it takes reliability testing from 500 hours to 200 hours. Apparently, Bosch did some work in that area, and so we're going to do, if this project flies, we're going to expand upon that and see, what's the difference between the failures at 200 and 500, and then how much over 200 do you have to go to get to similar 500. So big project, and it's in a really idea stage.
How has the COVID era affected your progress in terms of working on all of these activities?
It was a challenge for our members because a lot of the projects are tested internally by our members. And during COVID, as members were working remotely, they did not have access to their labs. So some of the projects were delayed a bit until the technicians and engineers were able to get back into the labs to complete the projects. But now we're seeing operations getting back to normal for the most part. So, for the last 2 years, we ran virtual meetings. Now we're starting to get back to live meetings starting in May. And we're all very excited about this. Our next member meeting is scheduled for May 18th and 19th in Austin. So we'll be gathering there. We expect to have a number of projects closed out at that time as more results are coming in and people are able to share the results, write the reports, and get that presented to members. As we get back to live meetings as well, I should say that we're structuring the meetings, and Jack manages the agenda. we're structuring the meeting so that the first day we can invite non-members to attend so they get a flavor of how HDP operates with our idea and definition phase projects and listen to the guest speaker that Jack talked about. We have a factory tour that will be, or facilities tour of Novacentrix that will happen on the first day of that meeting as well on May 18th, and dinner that evening. So non-members are welcome to attend that meeting, the first day of that meeting. Just need to contact me and I can get them organized.
Okay, so those dates again are May 18th and 19th in Austin, Texas.
Yeah.
And folks can contact Madan if they'd like to sit in. If you're not actually a member, you can sit in on that first day of the event. This is sort of just a little bit of a highlight, but I understand that one of your facilitators has some bragging rights. Bev Christian.
Yeah, I'm sure you know Bev.
Of course. Yep.
Everybody knows Bev. Bev is an expert. He was awarded the Dieter Bergman Fellowship Award, and I think everybody knows who Dieter Bergman is if you're in this industry. This is an award given by IPC International to individuals, and I'll quote what they write on their website. Individuals who have fostered a collaborative spirit, made significant contributions to standards development, and have consistently demonstrated a commitment to global standardization efforts and the electronics industry. So Bev won that award this year. The tangible benefit of that is that he got to bestow a Dieter Bergman Memorial Scholarship to the chemistry department of the University of New Brunswick, Fredericton, New Brunswick, Canada. We're very proud of Bev.
Well, that's great. And yes, I worked for Dieter for a couple of years at IPC, and I can't say enough in his memory. And also, I mean, Bev is absolutely worthy of that award. Absolutely.
I was in awe of that man, Dieter Bergman. When I was a young engineer, I did some work for IPC back in the 80s.
Dieter was a force of nature. I mean, he was a portal. He was just a way of accessing just a whole nother world of how to look at something. Well, I'm glad to see that you're going to return to face-to-face meetings. And I want to remind everybody that if they want to learn more about HDP, you are invited to visit their website at hdpusergroup.org. So we are coming to the end of our time. I'd like to thank Jack and Madan for bringing us up to date on the latest HDP research. For PCB Chat, this is Mike Buteau. Have a nice day.